In this video we're going to try and sketch this rational function. So when given a rational function, try and figure out when it will break down. Well, it will break down when the denominator equals 0, meaning when x equals 0 the whole thing will break down. So something weird's happening dead on 0. We need to investigate what happens just to the right of 0. So just to the right of 0, in your mind picture a really small number, and when you put it into here and square it, it would be an even smaller number. So imagine it as being like a really small number, and then you take away 4. You see, this thing here is going to be irrelevant. This 4 here is going to dominate the whole thing. So when x is very small, you can think of the numerator as being the number -4, because this is just going to be irrelevant. And then this thing here, well, 2 times a very small number, and it's on the positive side, meaning this is going to be a positive, very small. So in your mind picture a really small number and it's positive. When you get 4 divided by a very small number, so when you have a number, let's say 7 or 2.9 or 8 or whatever, and then you divide it by a very small number, this whole thing here is going to be very big. But then you've got a negative here, making it very negative big. So when I say negative big, you've got to think of a big number and then stick a negative in front of it. So just to the right of, when x is just to the right of 0, it's going to jump all the way down here. So it's going to jump all the way down here. So you know it's going to do something like this. And then now use the same argument just to the left of 0. So in your mind picture negative 0.00000, I don't know, let's say 4. And then when you put this into here, when you square it, the negative goes away, and it's going to be very close to 0. So in your mind picture a really small number, even smaller than this. But anyway, when you take away 4, don't forget this is a positive because you've just squared it. And then you take away 4, this thing here, the numerator, we're just going to be it's just going to act like roughly a 4, because this thing here is just irrelevant in comparison to the 4. So it's just going to act as a -4. And then this thing here, because you're on the left hand side, meaning a negative, times a 2, well, 2 times a very small number, it's going to be very small, and you've got one negative here because x is in the negative side, so it's going to be negative very small. So now 2 negatives, they're going to cancel each other out. So this 4 divided by very small, 4 divided by very small, is going to be very big. And don't forget it's a positive big because the 2 negatives cancel each other out. So it's going to look something like this. It's going to jump up here because it's going to be positive very big. So far we know this. So far we know that it's going just to the left of 0 is going to be very big. Just to the right of 0 is going to be very negative big. Now we need to investigate what happens when x is very big. Let's say 1000. When you put 1000 into here, 1000 squared is going to be 1 million, take away 4. Well, this block here is going to be so much bigger than the number 4. It's like me saying you're a millionaire and someone steals $4 away from you. This 4 is really irrelevant. Okay, if 1 million is not big enough, let's consider when x is, I don't know, a million, and then 1 million squared is going to be a massive number, and then you take away $4. It's not. This 4 is really irrelevant. So when x is very big, the numerator is just going to act like x squared. And then this thing here, well, let's just imagine it as this. So now you got x squared divided by a block of 2 and then a block of x. That's just going to be like a half x. So when x is very big, you can imagine it. You can draw a graph of y equals a half x. So that's a gradient of a half. So it's going to look like this, but only when x is big, because when x is small, is this 4 becomes more significant, because imagine you've got $3 and then you take away 4. If you have $3, you take away 4, that 4 is significant, is going to be important. Whereas if you're a billionaire and then you take away 4, this $4 is not really going to be significant. So this thing here, when x is very, very big, it's going to act like this thing here. So it's going to act like a graph y equals x over 2, which will look like this. Okay, so now let me just clean this up. So now let's imagine what happens when x is very, very negative big. Let's say negative 1000. So when you put negative 1000 into here, negative 1000 squared, well, when x is negative big, you can imagine the numerator is going to act like the same thing. It's going to act like this. This 4 is going to be irrelevant. So simplify this, it will act like this, over 2, which is y equals a half x. So it will act like this as well. So hang on. So when x is very, very big, you've got to picture y equals 1 over 2x. So that looks like this, a straight line with a gradient of a half. But only when it's big. Only when it's big. So we know it's going to do something like this. When it's big, we know it's going to do something like this when it's negative big. So now you can guess that it's going to do something like this. It's going to do something like this. And then if you want to know where it crosses the x-axis, put 0 into the y. Put 0 into the y and figure out what value of x will make y 0. So times both sides by 2x, so that would then be this thing here. So x equals plus minus 2. So this must be 2. This must be negative 2. Negative 2. Negative 2. And then if you jump to a graph plotter and plot this, it will look like this. It will look like this. So now you can see your line, your straight line. So when x is big, it wants to do the blue line. And then if x becomes really, really big, it will lie pretty much on top of this straight line. And the same goes in the negative realm. Dead on 0, it breaks down. You can see it crosses over at 2 and at negative 2. Okay.